Hi, I'm Joshua Hanlon from Beyond the Brick, and I'm here at the first LEGO League qualifying tournament at Grace College in Winona Lake, Indiana.
My name is Dr. Kristen Farwell. I'm a math professor here at Grace, and now I'm also the tournament director of the Grace College qualifying tournament First LEGO League. So First LEGO League is a competition started back in 1998 with only about 200 teams. Now it's grown to over 20,000 teams in 61 countries, so it's a pretty big event now. And they have to build autonomous robots out of Legos and using the NXT system. There are 22 teams total. The age range is from 4th to 8th grade.
There's actually 4 parts. Not only the robot part that you see, but there's also the students have to present a robot design presentation to some engineers. They have to do a core values or teamwork presentation to some judges. These themes are themes that are focused on senior citizens. If you look in the middle of the table, this ramp is to symbolize balance issues that senior citizens face. So the challenge is to get your robot to drive up on there without tipping and falling over. This tower-looking object right here is what senior citizens face when they're trying to reach things up really high or down low. You've got gardening activities, so you have to bring the other gardeners' plants to the garden. You got quilts, so bring the quilts. You got woodworking, so activities that seniors like to do.
I'm Bo Eckel.
Ethan Hoff.
Hunter Haynes.
Jared Barber.
Okay, so thank you. And your team name is the Granny Busters, and so you have your robot here. You just want to show us and some of the techniques you use to build it.
The main part of our robot, the best part of our robot, is probably this door hinge thing. If we didn't have that, we couldn't do any of our tasks at all. We chose, instead of having front wheels, we decided to put sliders on it, so we didn't have to design any special kind of wheel that turns and everything with the back wheels.
I'm Kristen Swanigan with Edgewood Middle School, and I coach the Granny Busters. Our teams are involved because as part of our Science Plus curriculum, which is an honors science class for 8th grade, they build the robotics right into it. So the kids do this for 9 weeks. Well, LEGO mandates that as a coach, I'm not allowed to touch their robot, I'm not allowed to touch their presentations. I'm there to solve personality conflicts and technical difficulties. So that's what I've done. So 3 to 4 kids did the research component where they chose what their topic was going to be, what they wanted to talk about. So like one of my groups decided they wanted to build a hearing aid that would be voice recognition. So they built that, and then the other part of the team was doing the programming.
I'm going to talk a little bit about how the robots navigate the field because they all are autonomous robots, which means there's no remote controls or anything. I think if you watch some of the videos, you'll see a lot of these robots just moving around with like move block programming, but really the next level of programming is using some of the sensors that come with the NXT brick. So we'll go over a couple of these, and if you take a look at the mat, you'll see some specific lines that are black and green. So you can navigate that 2 ways. One is the light sensor, and basically it detects intensity of light. So you can detect whether it's brightness or darkness, and so you can easily have the robot programmed to follow a certain brightness or darkness of a line. So you can use this a lot to detect things. Hey, stop when you find this black light. You can even, a lot of the good groups will take 2 of these light sensors, and you can even like square up. You know, knowing that your robot's perpendicular is really important. So as your robot's turning into a black line, as it detects it, it'll stop, and that's also a really valuable tool. And a lot of these kids haven't really got to that concept yet because we have 16 teams here that I believe are rookie teams. So that's something that in the years that they'll do in the next couple of years that they'll learn to do that. You also see some colors, like some greens this year. There also is a colored sensor. Works very similar like a light sensor, detects certain colors, and then you can tell it to do whatever it wants. You can follow green lines, you can follow blue lines, you can detect blue, green, reds, oranges, yellows with this. You can also, this can also act like a light sensor as well, depending. And you can see how, if you look at the end, they're a little different. So besides that, there's other ways to navigate around the board that we use a lot. Touch sensors. So you can use touch sensors, whether it's pressed, bumped, go forever until you run into a wall, and that's when you use a touch sensor. Instead, what they're doing now is they're saying, robot, go for X amount of seconds, or go for X amount of rotations. And if your robot's really charged, like you charge it overnight, it'll go a little bit farther than normal. So that's what you have to do, is what I call smart reckoning, using some sensors. That way, regardless what your battery power is, regardless of some of the variables on the table that you can't control, you can identify where and when your robot needs to start and stop and turn and do all those things. And the last one for this event that's really helpful is the ultrasonic sensor. It detects how far you are away from certain objects. So there might be a mission model on the mat that you want to be 2 or 3 inches away. What you do is you would position this sensor appropriately on the robot and then program it to stop 2 inches away from said object. So you can use this, and I'm sure there's a lot of groups that use it a lot more creatively than just that. But those are some of the basics of the sensors and how to navigate the board.